Hi friends, today I am giving a lecture on implementation of higher order decoder using lower order decoder. One example for this one is implementation of 4 by 16 decoder using 3 by 8 decoders. In this video, we have to discuss this example. Okay. Now, first of all, we can go to the 3 by 8 decoder. 3 by 8 decoder. As the name implies, here we are taking 3 inputs that are A, B, C. 3 inputs. Here that means n is equal to 3. N is nothing but number of inputs. Okay. How many number of outputs that are generated? That is 2 power n outputs are generated. That is 2 power 3. That is equal to 8 outputs are generated. That 8 outputs are D0 to D7. Okay. Among the 8 outputs, only one output is active high and the remaining outputs are active low based on the combination of inputs A, B and C when the enable input E is equal to 1. So, enable input is used for controlling the operation of a decoder. When the enable input value E is equal to 0, all the decoders produce the output as 0, but we are not applying any inputs. Okay. When the enable input value E is equal to 1, okay, the decoder operation can be performed successfully. Among the 8 outputs, only one output is active high. Okay, this can be done when the enable input value E is equal to 1. Okay, suppose enable input value is equal to 0. Without applying the inputs A, B and C, all the decoder outputs, that is D0 to D7, produces 0. 0 as the output. Okay, now we can go to the 4 by 16 decoder. Okay, so as the name implies, here I am taking 4 inputs. The 4 inputs are A, B, C and D. So therefore we can say that n is equal to 4. Number of inputs n is equal to 4. If the number of inputs n is equal to 4, how many outputs that are produced? That is 2 power n, that is 2 power 4, that is equal to 16 outputs are produced. So the 16 outputs are D0 to D15. D0 to D15. Total 16 outputs are generated. Among the 16 outputs, only one output is active high and the remaining outputs, 15 outputs are active low when the enable input E is equal to 1. So this is the operation of 4 by 16 decoder. Now, so for 3 by 8 decoder, 4 by 16 decoder is higher order decoder. Okay, 4 by 16 decoder is the higher order decoder when the lower order decoder is 3 by 8 decoder. Now, implementation of higher order decoder, that is 4 by 16, using lower order decoder, that is a 3 by 8 decoder. Okay, so how many number of lower order decoders are required? That is a 3 by 8 decoders are required to implement 4 by 16 decoder. Okay, by using the following formula. So required number of lower order decoders is equal to M2 by M1, where M2 is nothing but number of outputs of higher order decoder, where M1 is number of outputs of lower order decoder. So here higher order decoder is 4 by 16. Here how many number of outputs? This is the input and this is the output. So that is M2 is equal to 16. Number of outputs of higher order decoder. So is nothing but this is the output. So therefore M2 is equal to 16. Next, whereas lower order decoder, number of outputs of lower order decoder is 8. So therefore M1 is equal to 8. This is the inputs and this is the outputs. This is the lower order decoder. So 8 outputs are there. Therefore M1 is equal to 8. This is the higher order decoder and 4 inputs, 16 outputs. So that M2 is equal to 16. Okay. So when we are observing the M1 is equal to 8 and M2 is equal to 16, we are substituting in this formula. Therefore, required number of lower order decoders is equal to 16 by 8. That is equal to 2. Okay. 2 3 by 8 decoders are required to implement 4 by 16 a decoder. Okay, how many number of lower order decoders are required? That is 3 by 8 decoders are required to implement higher order decoder, that is 4 by 16 is 2. Okay, 2 3 by 8 decoders are required to implement the 4 by 16 decoder. Okay, so here this is the first 3 by 8 decoder and this is the second 3 by 8 decoder, because 2 3 by 8 decoders are required for implementing 4 by 16 decoder. So this is the first one and this is the second one. Okay. For the first 3 by 8 decoder, okay, how many number of inputs are there? 3 inputs. How many number of outputs are there? 8 outputs. 3 inputs are A, B, C. So these 3 inputs are connected to the first 3 by 8 decoder. Then it produces how many number of outputs? 8 outputs starting from D0 and ending with D7. 8 outputs are generated D0 to D7. Okay. Among the 8 outputs, only one output is actively high when the enable input E is equal to 1. Okay. When the enable input E is equal to 1, okay, then among the 8 outputs, only one output is active high based on the combination of input values A, B, C. Okay. When the enable input E value is equal to 1. Okay. Now, go for the second 3 by 8 decoder. Okay. So, it can take 3 inputs. Here A is connected to the second 3 by 8 decoder, B is connected to the second 3 by 8 decoder, C is connected to the second 3 by 8 decoder. Now the second 3 by 8 decoder contains 3 inputs and it produces 8 outputs. These are the 8 outputs starting from D8 to D15. Here D0 to D7 are the outputs of the first 3 by 8 decoder. D8 to D15 are the second 3 by 8 decoder. But here how many number of outputs are there? Total outputs of 2 decoders. So 16 outputs. For 16 outputs, how many number of inputs are there? 4 inputs, but 3 inputs are there. Then fourth input, the fourth input D is connected to the enable input of the second 3 by 8 decoder directly. So D is connected to the enable input of the second 3 by 8 decoder, and the complement of D is connected to the enable input of the first 3 by 8 decoder. So for complement of D, we have to use NOT gate. NOT gate is used for the complement of input D. The complement of D is connected to the enable input of the second 3 by 8 decoder. Okay. Only D is directly connected to the enable input of the first 3 by 8 decoder. Okay, so if the input D value is equal to 1, okay, it activates the second 3 by 8 decoder. If the D value is equal to 0, okay, it the first 3 by 8 decoder is implemented. Okay, so enable input value is equal to 1. So D value 1 means enable input value is equal to 1. Okay, then the second 3 by 8 decoder is operated. Among the 8 outputs, only one output is actively high. Okay, so if the D value is equal to 0, it is connected to the 3 by 8 decoder. Among the 8 outputs, only one output is active high. Okay, so this is the operation can be done. So fourth input D value is directly connected to the enable input of the second 3 by 8 decoder. Okay. Complement of fourth input D is connected to the enable input of the first 3 by 8 decoder, because enable input control the operation of the decoder. Okay. This enable input can be taken as the fourth input. Okay. If the fourth input value is equal to 1, this decoder is operated. If the fourth input value is 0, this decoder is operated. Okay, now the input D can be acts as a control of the 4 by 8 decoder, because D is connected to the enable input. Okay, this is the implementation of 4 by 16 decoder using 3 by 8 decoder. This is the higher order decoder and this is the lower order decoder. So we have to implement the higher order decoder, that is 4 by 16 decoder, using two lower order decoders, that is a 3 by 8 decoder. Generally, this is the block diagram of a 4 by 16 decoder. So here, as the name implies 4 by 16, so 4 inputs, that is A, B, C and D. Okay, it can generate 2 power 4, that is a 16 outputs starting from D0 and ending with the 15. Okay, so among the 16 outputs, only one output is active high and the remaining outputs are active low based on the combination of input values. So this operation can be done when the enable input value E is equal to 1. Okay, suppose E is equal to 1. Okay, the decoder is in a active position. Okay, now I am taking A, B, C, D values. Okay, A value is 0, B value is 1, C value is 1 and D value is 0. Okay, so 0, 1, 1, 0. So A value is 0, B value is 1, C value is 1 and D value is 0. 0, 1, 1, 0. What is the equivalent decimal value? That is a 6. Okay, so now D6 output is active. Okay, so D6 output is active and the remaining all the outputs, that is 15 outputs, is disabled. Only it is enabled, the remaining 15 outputs are disabled. Okay, so that is D6 is active high. D6 is active high. Remaining outputs are low, active low. So this is active low. Okay, in the same way, another one I am taking E is equal to 1. So A, B, C, D, that is 1, 1, 0, 0. Okay, what is the equivalent decimal value? That is 12. So D12 is active and the remaining D12 is active and the remaining all are in active low. Okay, D12 is in active high and the remaining outputs are active low. Okay, so in this way, a 4 by 16 decoder can be implemented. So the same 4 by 16 decoder can be implemented by using 3 by 8 decoder. Okay, so this is the first 3 by 8 decoder and this is the second 3 by 8 decoder. Okay, 3 inputs are connected to the first 3 by 8 decoder and same 3 inputs are connected to the second 3 by 8 decoder. The first 3 by 8 decoder are D0 to D7 and the second 3 by 8 decoder outputs are D8 to D15. So 3 inputs and 8 outputs, 3 inputs and 8 outputs. Okay. Now, where is the fourth input? Because 16 outputs are there, here only 3 inputs are there. Where is the fourth input? The fourth input D is connected to the enable input of the second 3 by 8 decoder directly. So, D is connected to enable input of second 3 by 8 decoder directly. Okay, the complement of D is connected to the enable input of the first 3 by 8 decoder. Okay, that means if the D value is equal to 1, this decoder is enabled and this decoder is disabled. If the D value is 0, so this decoder is enabled and this decoder is disabled. At a time, only one decoder is in active position. Okay, so D value 0 means this decoder is in active high. This decoder is disabled. D value is 1 means this decoder is in active high and this decoder is active low. Okay, so for example, I am taking among in this decoder which output is active and which outputs are inactive. In the same way, in this decoder which output is active and which output is inactive, we have to check this. Okay, now see example. So that is a D, A, B, C. Okay, so I am taking D value 0, so that is 1, 1, 0. Okay, so D value 0 means, okay, this decoder is enabled. Okay, what is the A, B, C values? A value 1, A value 1, B value 1, C value 0. 1, 1, 0. What is the equivalent decimal value? That is 6. 6 means, so D6 output is active high. Okay, D6 output is enabled or D6 output is in active high, but the remaining outputs D0, D1, D2, D3, D4, D5 and D7 are in disabled or are in active low. Okay, for example, so if D value is 1 means, okay, it can goes to this decoder is enabled. A value 0, B value 1, C value 1, 0, 1, 1. So 1, 0, 1, 1. 1, 0, 1, 1 means, so that is the equivalent decimal value is 11. 11 is nothing but D11 output is enabled and the remaining D8, D9, D10, D12, D13, D14 and D15 are disabled. Okay, next I am taking another one D, A, B, C. So that is a 0, 1, 0, 1. Okay, here D value is 0. D value 0 means this decoder is enabled. Okay, then 1, 0, 1. A value 1, B value 0 and C value 1. So what is the equivalent decimal value? That is a 5. So D5 output is active. Okay, the remaining outputs are disabled. Okay, only D5 is enabled but the remaining outputs are disabled. Okay, next in the same way D, A, B, C is 1, 0, 1, 0. Okay, here D is equal to 1 means, so this decoder is enabled and 0, 1, 0. A value 0, B value 1 and C value is 0. Okay, D value is 1, 1, 0, 1, 0. That is D10 output is enabled and the remaining outputs D8, D9, D11, D12, D13, D14, D15 are disabled. Okay, so in this way implementation of 4/16 decoder using two 3/8 decoders can be implemented. Okay, so thank you for watching this video. If you like this video, please subscribe my channel name. So, DIVVELA Srinivasa Rao.